Okay, so tomorrow your written test number 2. Just make sure you go to the enroll session either in the morning or the afternoon. I'll send you some reminder about the rules of the written test, but it'll be the same as the first one. So there should be no surprise in terms of the format or the rule. And the review material I did on Sunday, it's been released. If you want to check out the review session, feel free. It might help. And your lab number 4 is due this Friday at noon. And then I'll release your last lab in time this Friday. That'll be the final lab, but still very valuable for your learning. But just make sure you complete your lab number 4 as much as possible and submit in time to claim your credits. And your programming test number 3 will be next Wednesday, not the coming one, but next week. And I'm going to release the guide to actually give you the expectation about the programming test, but it's going to be heavily rely on lab number 4, for sure. That's something I can tell you already. And for your programming test number 2, the result and the feedback have been released. If you got any issue you want to talk about, please don't send email, just come to me. Come to my office hour during the Zoom, or maybe in person today and Thursday. Or if you want to make an appointment, let me know. All right, any question about the course? Yes. Is there a breakdown for what's going to be there? What do you mean breakdown? The coverage is actually on the PDF guide. So if you check out the PDF, yeah, you see the coverage. Are you more asking about what questions are there? Yeah, it's already posted. Yeah, since a long time ago. You better check it out. Yeah, before tomorrow. All right. Yeah, go to the lecture site. You'll see a PDF guide there. All right. Good. All right, guys. Any other questions? All right. Let's now recap about last Thursday. All right. So last Thursday we continued with our inheritance discussion, especially number 1. Without inheritance, it would be very, very inconvenient for us to create multiple arrays because resident student, and non-resident student, they're different classes. You have to have separate arrays to handle the implementation. And once we get to the deep into the inheritance, we're going to see something that's going to simplify the matter a lot. So I would say keep this one here as your reference point. Once we see how to do things properly using inheritance, you can see the contrast. And for this page here, we summarize this about in a subclass, what can you do? So there are 4 things you can do. Number 1, you cannot redeclare attributes. They are simply inherited. Number 2, you can add new methods or new attributes into the subclass. One thing you should know right away, since we talk about expectation for the static type, what does that mean? That means potentially the child class can always have equal or greater than expectation compared with their parents' class, right? Because you can simply add new methods and new attributes. Whenever you're adding new things into the class, you're creating more expectation for that particular class. And we're going to play with this word expectation a lot today when we do the principles and example. Number 3, for the inherited methods, if you're simply happy with them, you don't need to redeclare them. They're automatically inherited to you. You can use it. And the final case will be for the inherited methods, if you're not happy with them, you can redeclare them, override them, pretty much like the equals method for point V2 that we spoke about earlier. All right, this page here is very important for you to know what you're allowed to do in a subclass. All right, and you guys asked me about multiple inheritance, but that's only for your knowledge from before. And we talk about visualization. So whenever you're visualizing the parent's object, just remember all the attributes from the parent class will be inherited as part of the visualization of the child objects. In addition, for example, resident students has some additional attributes that's unique to that particular class because that's new attributes. Similarly, for non-resident students, you also have a new attributes premium discount rate. That's also unique to that particular subclass. Right? You really have to know how to visualize parents versus child objects. It's going to help you trace the code and also understand more insights into inheritance. All right, so that one is about tracing the code. I also highlighted the points you want to really watch out for when you actually trace the code, right? You want to follow them when you do your study. And for that one here, you can also refer to the in-lab demo video as well. I kind of show to you how you can create classes using inheritance from scratch. That's a very important exercise for you to do. Of course, you'll do that anyway in lab number 4. All right, we talk about modifiers. So there are 4 possibilities for attributes and methods. It could be private, protected, public, or simply no modifier. So these are the 4 possibilities. And for class, it's easy. Only 2 possibilities, either public or not public. Okay. And we spoke about different cases. You should really download the source code I made available to you on the class site and play with them, right? That's also covered in the common written test as well. So you want to study them. And that's the table summarizing the visibility for different visibility for the attributes and methods. So we only spoke about visibility for attributes in the class, but the visibility for methods will just be similar. Okay, just basically the same. Right? So that one there, we also covered implicitly. And after that, we talk about this very important page as well. We talk about expectation. Whenever we talk about expectation, we really talk about static type. Static type means the types that's declared to be the type of the of the reference variable. You can see S has a static type over here. RS has a static type here, and etc. Right? Just always remember, once you know the static type for the reference variable, you can determine the expectation. And more importantly, if you look at the expectation for S, which is a parent static type, in that way you only got certain attributes that's already declared in the parent class. On the other hand, when you got RS and NRS, they are the subclass static type. In that way, number one, they will inherit all the expectation from the parents. That's for sure, always the case. That's why I said the expectation for child classes will be larger than or equal to the expectation for the parents. You can see that very easily, actually, from this table here. So what will be in addition? For RS, which is a resident students, the additional expectation we can have will be the additional attributes and methods we declare in them, premium rates and set premium rates. But they don't have the expectation that's specific to the sibling class, like a non-resident student. Right? You got to be very clear about which class you're talking about. And similarly, for NRS, which is another subclass for students, number one, you inherit all the expectation from the parents. You also got the additional expectation, which correspond to the discount rate and set discount rate that are newly defined or newly declared in this subclass. On the other hand, for the sibling expectation, you simply have no expectation on that. All right. So this table here really tells us a lot about the rules. You want to be very clear about what's going on. And what we're going to talk about from today's lecture and so on also depends on this. That's why I talk about this example first. And the final topic we spoke about was this one here, to give you some intuition about polymorphism. So polymorphism is really about doing some assignments, but I'll speak a little bit more about definition later. This is only for intuition. Of course, for the details about why, this one here should compile, but this one here should not compile. For the detailed reasoning, you want to refer to the lecture notes and also recording. I'll leave you to that. But what I want to say is, whenever you got the right-hand side as the assignments, well, the right-hand side to the assignment, for example here, if this is a subclass, static type, it would be okay if you assign some subtype, subclass, into some parent class, static type. That's something we'll elaborate a little bit more today. All right, any questions from last time? Yes? Mm-hmm. Okay, so for private attributes, private attributes in the parent class by the rules are not inherited to the subclass. So there's, number one, they're not visible because they are simply not inherited. You cannot refer to them. So if they are really attributes that you want to reuse in the subclass, you better make them protected. Yeah. Mm-hmm. Yeah, that's to do with visibility, which you can also refer to the previous discussion. All right, any other questions about last time? All right, if no, let's now have another intuition about dynamic binding. Okay, let's do by example. There we go. Let's start with this page here. Okay, dynamic binding. Dynamic binding simply tells you that the dynamic type for the reference variable of the reference variable might change from one into another. So let's now take a look at the piece of code over here. So in this line here, we have created EECS2030. So this is the course objects. Easy. Okay. And we declare S over here of static type students. Right? You want to annotate yourself right away. The students over here is the static type of S, which never changes. And then we have another two variables, which are pretty much like the setup from before. We got RS, we got NRS. All right? And for RS, it's pointing to some resident students objects. For NRS, it's pointing to some non-resident students objects. And the title of the box, as we said earlier, is the dynamic type. So think about this guy over here, resident students, and also this one here, resident students. That's the dynamic type for now, because dynamic type may change later. Similarly, if you got this one here, non-resident students, which correspond to the title of the box over here, that one is also the dynamic type. Okay? And we can also set the premium rates 1.25 for this resident student objects. We can set the discount rate here as well. That one's also easy. And we can also register both of them so they become classmates. That one I can draw quickly. That one there, basically the first course will be here, and this here will be here. Right? Just remember we talk about composition versus aggregation. Apparently this one here is aggregation because we got sharing, right? All right, let's now talk about what's really dynamic binding. Number one, you want to look at or label them. You want to think about different timings. So let me say 1 and 2 over here. Right? So there are two timings. All right here. So we basically talk about before 1, after executing 1, and also before 2, and also after 2. Right? I'm basically talking about right before executing this line, right after it, and then right before this one, and right after it. We want to talk of different timings and see how the static type and dynamic type might change. Okay. So now, number one, we want to say the static type of S. And another column will be the dynamic type of S. Right? So these are the two things we want to work out. Static type versus dynamic type. All right, let's now talk about all these entries in the table. That's the best way to really see what's going on. The first column here, you can answer right away without any thoughts, because S here, declared to be students, never changes static type, always the same. So all you can do will be, you just say, the static type will just be students for all the entries. Always. Never changes. And what we want to work out will be, how about dynamic type? Okay, this will be one row here. This will be another row. This will be another row. All right. What about dynamic type? Before this line over here, S was not even initialized. You can think about S could be maybe just over here, right? It just declared. There's no object that's being pointed to. It's just null. So you can think about, you can either say unknown or you can just say null, right? What about executing 1? And we know that 1 is allowed based on what we discussed about polymorphism last time. That one there is going to let S point to wherever RS is pointing to, which will be over here. As soon as we have this, we're going to change the dynamic type. So after 1, S will be pointing to resident students. All right. As soon as we have done this, let's say we try s.getTuition. And notice one thing here. There are 3 versions of getTuition in our architecture here. We got the base amount version, getTuition here. We got an overridden version for resident students. We got the getTuition also overridden for non-resident students. So we got 1, 2, and 3. Dynamic binding intuitively tells you that whichever version you're going to call depends on the dynamic type. Okay? Not the static type. Static type is only about compilation, whether something will compile within the expectation. Dynamic binding is about once things compile, you're going to execute it at the runtime. So now, what version is going to be called? Because we know that at this point here, for S, dynamic type is resident students. So we know that getTuition over here is actually going to call the getTuition over here. Okay? So the resident students version will be called, which is going to sum up the base amount, which will be 100 multiplied by 1.25. That's the answer. The actual number doesn't really matter, but it's important for you to know which version it is going to call. All right, next one. So after calling this, let's say right before we try to execute number 2, dynamic type for S still remain to be RS. Doesn't change, hasn't changed just yet. So I will still put RS over here. And then we're going to execute number 2, which is going to execute this reassignment here. And we know from last Thursday, this is allowed. So S, rather than pointing to over here, is going to point to wherever NRS is pointing to, which will be over here. This effectively changed the dynamic type for S, right? So after number 2, we know that dynamic type of S has been changed to non-resident students, NRS, right? And then when we try to execute this line here, after that, getTuition, because we know for S here, dynamic type is actually NRS. It's going to determine which version of the getTuition is going to be called. In this case, it would be this version over here, which is the version in non-resident students, which corresponds to the dynamic type for S at the moment. Later on, we're going to learn about an operator in Java that shows you how you can check dynamic type, but not yet. We need to talk about typecasting first before that operator. All right? You might be thinking about getClass method from the equals method lecture, but I would say that one might turn out to be a little bit restricted. So don't worry about it just for now. All right, one more thing to say. If you try to call this getTuition here, it's going to call this version here, which is going to use the discount rate as opposed to premium rates from before. So make a final notes. So NRS version will be called. All right, guys, any question? If you really get this this example here, almost 100%, you pretty much understood everything you need to know about dynamic binding. But we're going to make it a little bit more formal and more example just to reinforce. Jennifer. Yeah, you can say that, yes. So, of course, we separately be 2 phases, compilation and runtime. As far as compilation is concerned, number 1, we got to check to see whether this assignment here should be allowed. And that should be allowed based on the reason we talked about on Thursday. And for this method called I agree, this one here is going to look at is the static type of S, which is students, does it support getTuition? It does. There's at least one version over here that's supported. But at the runtime, because S may be dynamically pointing to some subclass type, which is dynamic type. In that way, rather than calling the base version here, we're calling this version that corresponds to the dynamic type. It's a different issue here. So we talk about compilation versus runtime. Yeah, question. You mean, for example, you mean, for example, oh, we register, right? Over here. Okay, yeah, for sure, you can do that as well. As long as you're pointing to the right object, that should be okay. But at this point here, we're setting up the object, so that's why we're using RS and NRS. That's different. Yeah. Feel free to modify the example to see if they still work. Yeah. But a more interesting method here to discuss for dynamic binding would be gate tuition, because you got more than one versions available. On the other hand, for register, there's only one version because it's never overridden in the subclasses. All right. If everybody is good, let's now move on. Okay, so, and the inheritance hierarchy that we spoke about right now, up to now, is pretty easy. There are only three classes, basically one parents and two child classes. But in general, you definitely can have some multi-level inheritance hierarchy. That's something I'll have to show to you. Right? So this is the intuition that we just spoke about, right? So I'm going to give you two examples, and one of them we're going to use as a running example for later. So multi-level inheritance hierarchy. So here you can see at the top we got students. Let's say we introduce a middle layer. Under students, we have either domestic or foreign. For domestic, it could be either resident or non-resident. For foreign students, it could be either resident or non-resident. Right? You can see the idea. So we got multi-level. As far as this class is concerned, the parent class is domestic student, for example. As far as this class is concerned, this class here is a parent class, and etc. And we're going to generalize the term about child and parents into something, which we're going to see very soon. And there will be some reflection question for you guys to think about, right? Well, if you think about back to last Tuesday, we talked about two designs without inheritance. Design number one, we use the attributes called kind. If you recall, integer. If you try to implement this inheritance hierarchy over here using the first design, what will be the complication, right? In this case, how many classes do we have? We got one here, one here, one here, 1, 2, 3, 4. We got 1, 2, 3, 4, 5, 6, 7. We got 7. So you need 7 different numbers to encode different kind, right? So that's going to introduce extra complication. And for every method in design number one, you got to say if kind is equal to 1, else if kind is equal to 2, all the way to else if kind is equal to 7, right? Very inconvenient. What about design number 2, without inheritance? That one there is going to have basically 1, 2, 3, 4, 5, 6, 7 separate classes. And we're going to have lots of duplicates of the code, which violates single choice principle very badly. And when you actually have another class called student management system, for each student type, you have to store that in a separate array. How many arrays do we need? Depends on how many classes you have in the hierarchy. So we need 7. All right? So my point is, you really want to go back to the previous two designs without inheritance and think about how inconvenient, how complicated it's going to be if you try to implement them, implement especially the multi-level inheritance hierarchy. And the final design, which will be using the inheritance, now you want to think about a much higher level of issues. You want to think about what attributes I should really put in the student class so that it will be inherited to all the child classes. And what should I put over here so that it will be inherited to all the child classes, and etc. It's a different issue you want to think about. Right? So for design number 1, 2, and 3, I'll leave the reflection to you, but you got to be clear about if I ask you later, maybe not in written test number 2, not, but maybe in the exam. If I refer to a particular design over here and then ask you to discuss how the implementation is going to go, you should know how to answer. Okay? All right, so that will be the reflection. Design 1, 2, 3 about this inheritance hierarchy. There's another one here, which is going to be something we're going to use as a running example. Okay, smartphones. And the models I talk about the smartphone here is pretty old. I do apologize for that, but you will get an idea. Okay, and let's talk about the hierarchy a little bit. We're going to talk about more details today as well. Let's say at the top, we got a class called smartphone. And there are only two basic functions you need from the smartphone. Let's say dial and also surf web. Basic. Every smartphone should really support these two functions specifically. And let's say under smartphone, we got either iOS or we got Android. Okay? For iOS, you choose to override the surf web method, maybe using Safari. Okay? And you got an additional method, like a new method in iOS called FaceTime. Let's say that's only available in iOS. And under iOS, I got iPhone SE and iPhone 13 Pro. Pretty old model, but you see the idea. And let's say there is one new feature or new method in iPhone 13 Pro. It's called Quick Take, let's say. Okay? So that's the story for this side here. And we got Android over here. And then we also try to override the surf web. But let's say now, rather than using Safari, it's going to use Firefox. And then for there's a new method there called Skype, rather than FaceTime, right? And under Android, we got either Huawei or Samsung, let's say. Every Samsung phone should really support a new method called Side Sync. That's specific to Samsung. And under Samsung, you got either Galaxy S21 or Galaxy S21 Plus, right? Finally, under Huawei, you got either this model here or this model here. And for this model specifically, we got a unique feature called Zoomage, let's say. Okay. And I made the diagram available also to you on the lecture site. You can take a look. Maybe after today's lecture, get yourself more familiar about the methods there. And the reflection will be the same for design number 1, 2, and 3. All right, I'll let you think about it. Okay. And we're going to dive way more into the smartphone hierarchy for today, for sure. But let's now move on. Okay, so let me now go back to the slides. All right, let's now talk about inheritance hierarchy a little bit more. And I would like to generalize the term about parents and child. That's something we will need. Okay, these 2 bullet points are basically what we said in the OOP review. What is really a type? A type is simply some runtime value that are related. And a class could be a type, in which case we talk about reference variable, right? All right, so whenever you talk about inheritance using the extends keyword, it creates a hierarchy of classes. And we have seen just 2 examples just a few minutes ago. Right? There's something very important for you to know. Implicitly, you can think about every class extends objects, but you never say that explicitly. You never say my class extends object. You don't say that, but just implicitly. That's why we inherit the equals method and every method and attributes in the object class. That is implicit. Okay? And each extends keyword is going to be an upward arrow. I'll show you that in just one moment. So here, let's see one example here. So let's say you have some class over here called X. And then you say X extends, right? You can see there's an upward arrow, extends Y. And there might be another class over here called Z that extends X. Right? So every time you have extends keyword, that simply corresponds to some upward arrow, extends. And you will say that X directly extends Y. You will say that Z directly extends X. You wouldn't really say Z directly extends Y. You only say indirectly. Okay? So the only thing I want to say aside would be Z indirectly extends Y. All right? Okay, let's see other things. Yeah, every class implicitly extends the object class, but you never write it out yourself. All right, so let's now generalize the term. I want to generalize child into descendants and parents into ancestor. The definition is pretty simple, but you need practice to really figure out exactly where they are. All right, then now go bullet point by bullet point, and then we'll do some example. What's really ancestor classes? Could be more than one. If I talk about some class A, what will be the ancestor classes for A? It would be number 1, A itself, include A itself, plus all the classes that A either directly or indirectly extends. Okay, so if you look at this diagram here, let's say we got some very complicated inheritance hierarchy over here. Let's say A sits somewhere in the middle. How do I figure out the descendants? Descendants go like this. It would be, number one, the A itself. And the class that A directly extends and also indirectly extends. You basically follow the up arrow all the way to the top of the hierarchy. So all the classes I highlighted in green, so they are called ancestor classes for A. Okay? So all these are called the ancestor of A. And what is so special about the ancestor of A? You want to think about what you can do in general in a subclass, right? We recapped that in the beginning. Because we know that everything that's declared over here is going to be inherited to A. Everything that's declared over here is going to be inherited to this guy here, which indirectly tells you everything that's declared over here will also be inherited to A, and etc. What does that mean? That means once you figure out all the ancestor classes of A, the union of all the attributes and methods in the ancestor will be inherited to A. That's a very important insight over here. Okay? The union of all attributes and methods will be inherited to A. Number one. Number two, what about expectation? Because everything that's declared in the ancestor will guarantee be inherited to A. A itself can also declare something extra. So A's expectation is guaranteed to be larger than or equal to any of the ancestor classes. All right, so number one. Number two, the expectation of A is larger than or equal to the expectation of any ancestor class. All right, number two is the conclusion. But in order to understand that, you really have to know how the code has been inherited from the top level all the way to that particular class. Right? All right, any question about ancestor? This diagram here is a little bit abstract over here, but it does help to generalize the thing. But once we get to some concrete example, we can do that concrete exercise as well. All right, so if we follow the direction for the arrow from A, we get all the ancestor. What about descendants? It will be the other way around. Okay, let's go back to the slides. Right, so that's something I just mentioned. So inherited all the codes from A, so that's why you got wider range of expectation. All right. What about descendants? So here's the definition. Descendants of A will be A itself again. So A is both its ancestor and descendant at the same time, by our definition. Okay? What will be descendants? Descendant will be A itself plus all the classes that either directly or indirectly extends A. Okay, so that will be the definition. Either directly or indirectly extends A. So if you go to the diagram here, how do I draw the descendants? Number one, I need to include A itself. And also all the classes that directly extends A, the first level here, and the first level here. So here, when I say dot, dot, dot here, that means maybe there are more than two sibling classes at this level. And then all the classes that directly or indirectly extends this class, they will be part of the descendant for A as well, right? So everything in this branch will be the descendants, okay? So this one here as well, and this one here as well. So all the ones are highlighted in pink. So these are the descendants. All right, so you want to know that, number one, A's expectation inherited to each one of them. To each of them, number one. And number two, each of the descendants has either equal or larger than expectation than A. All right? Or you can put it this way. The expectation of A is less than or equal to the expectation of any descendant class. Think about this abstract diagram here very carefully when you study this. All right, so expectation A is less than or equal to. What does that mean? Again, let's make a conclusion about this one here and this one here. If you're given a class hierarchy by inheritance, if you go from the top all the way down to the bottom, the lower you get to, the more expectation you have. Because you got more attributes and methods as you declare new subclasses. All right? Any question? Yes? That's correct. Yeah, because the lower, for example, if you compare one class, yeah, that's exactly right. So expectation is about the attributes and methods you can call upon the context objects of that particular type. If I have some class over here, I have another class over here. If I simply ask you compare these two classes, which one has wider expectation? This one here lower. Because, number one, this one guarantee is going to inherit everything from its ancestor, including this guy here. Plus, this class can also create new methods and attributes. So definitely wider range of expectation. All right, it's a very important concept to have because once we get to the rules about compilation, we need this insight. All right, question? Yeah, you can say that for sure. But however, I would say it's a very good insight. You can say that object is definitely one of the ancestors for any class. I agree. But I would say since object class is somehow implicit, so usually when we are given some class hierarchy, we don't really put object into the diagram. So I would say let's not worry about objects, even though we know that's true implicitly. Okay. All right, guys, enough about abstraction. Let's do some concrete example to figure out. All right, let's do this one together. Okay, so let's say we got our smartphone example over here. Okay, let's start with smartphone. Okay, what would be the ancestor for smartphone? Just itself. All right. So I'm gonna be a little bit lazy. I'll just say SP for smartphone. Smartphone, as far as this inheritance hierarchy is concerned, has no other class that it directly extends. So we don't count objects in this case. So only smartphone here, just ancestor. What about descendants for smartphone? Every class. If you talk about the top of the hierarchy, the descendants will be itself plus everything. Right? It's going to be all classes. And what will be the expectation for smartphone? Well, you got to look at the declaration. You'll be dial and surf web. So it will be dial and surf web. Okay? That's about smartphone. And let's talk about another extreme. What about Galaxy S21? What would be the descendants, first of all? Just itself. Agree? Because it has no other inheritance hierarchy underneath. All right? So this one here would just be Galaxy S21. All right? What about ancestor? Is it correct to say all the classes in the hierarchy will be ancestor? Not really. Can you tell me how many ancestors? Just tell me how many. 3 or 4? Not 3, right? If you're thinking about 3, because if I follow the arrow, I got this one here, this one here, this one here. You're almost right, except you got to count itself as well. Right? So ancestor will be basically this one here, this one here, this one here, and this one here. You basically follow the arrow. All right, that's the ancestor. All right, for that one there is going to be Galaxy S21. Also, you got Samsung, and also Android, and also smartphone. Right? These are the ancestor. What about expectation? Basically, for you to work out the expectation for this guy here, you want to work out the accumulated expectation from all its ancestors. So the best way to do will be like this. Think about this class specifically. Does it have any new attributes, methods? Not really. So no, nothing to add. How about its first level ancestor? It does. Size sync. I'll put size sync first. So I'm going to put size sync. That one is from here. And if I go up over here, I got Surf Web, I got Skype. I'll put Skype first. And also I got Surf Web. And if I go up here, I got Dial, that's left. So these are the expectation, right? All right, final one, let's be complete. Let's talk about iPhone 13 Pro, all right? This one here will be the descendants, also just itself, okay? Okay, let's put it down. That'll be iPhone 13 Pro. Okay, that'll be the descendants. What about ancestor? It will be this one here, and plus itself, right? So it will be iPhone 13 Pro, and also iOS, and also smartphone over here. Okay, and what about expectation? Number one is going to be some new method here in iPhone 13 Pro, which is quick take. Quick take. And then when I go up one level here, I got FaceTime. I got FaceTime over here. And if I go up another level, I got Dial and Surf Web. All right. Any question before I make a final remark? Okay, one thing that's interesting I would like you to see visually. And to really understand this kind of a structure here more systematically, I'm afraid that's beyond the scope of this course. You're going to take 2101 in the next term to learn about trees. But for this course, just get an example understood. That should be enough. If you look at these two subclasses, right? Even though they belong to the same hierarchy, what is the common ancestor for these two? Common ancestor. For example, this class and this class, they are different classes. Parents and parents, they are not the same. Parent here, also not the same. So the common ancestor, the only one we have is smartphone, right? Meaning that if you go this path over here, and if you go this path over here, the only place where they're going to converge will be this class over here. So that's a common ancestor. All right, I make that observation for you. So you can think about the ancestor, smartphone and smartphone here. So that is the lowest common ancestor. So this is the lowest common ancestor. Number one. And since we know that's the lowest common ancestor, that's where they have some shared inherited expectation. Because if you look at the expectation between this one here and this one here, what do they share? They only share Surf Web Dial and Surf Web, if you look at this one here and this one here, they only share Surf Web Dial and Surf Web Dial. That's from the common ancestor. All right? So that'll be the final remark. If you look at Surf Web and Dial and Surf Web, so that will be the inherited expectation from the common ancestor. Okay? So that one there will be the inherited expectation from common ancestor. All right? Just say one more thing. which you can just see the diagram. What would be the common ancestor for these two classes? How many common ancestor from the diagram? 2. This one will be a common ancestor. This one will be another common ancestor, right? Okay, I said I should really write it down for you. And for these two over here, the common ancestor will be iOS and smartphone, right? Alrighty. Very important exercise for you to feel free to redo it yourself too, right? Just take the piece of paper and then print out the diagram and then try to work out. Maybe you try to work out the expectation for different classes. Yeah. Mm-hmm. Mm-hmm. Which version? Let's say, for example, let's say the dynamic type for the method call is Galaxy S21, let's say, which is going to determine which version of the surf web that's going to be called. The way it works goes like this. At the runtime, it's going to look at, is there any overridden version of surf web here? No. Go to its immediate ancestor first. And then here, do we have any overridden version? Not really. Go up one level. Here, this is the closest one that has the surf web overridden. So that's the version. So there will be some example which I talk about at the end. So whenever you want to determine the overridden method, you basically start searching from the class itself for the dynamic type and go all the way up, follow along the ancestor path, and find the one that you look into first. In this case, it will be the surf web over here. Okay. That's actually something for later. All right, any question? All right, if no, let's see. Okay. All right, so that's about it. Let's now talk a little bit more about accumulation of code, which we already spoke about. But let's just go over some reinforcement here. So the lower a class is in the hierarchy, the more expectation you can have. That's something we said. And because in the descending class, we can simply declare new attributes, new methods. We can also overwrite methods. Consequently, this is something we would like to see very clearly. Okay? So let's see here. Let's see some example right away. Okay, that should be good. Okay, let's look at this example here. Let's say we have SP1, SP2, and also SP3. We got 3 reference variables. SP1 is declared to be of static type smartphone. All right, smartphone, which is over here. SP2 is declared to be iPhone 13 Pro. Okay, and then we got another one, Samsung. Over here, static type, and which is here. We got 3 different possibilities for the static type, for different variables. And what we want to know is, when we say we want to reassign SP1 into something else, what should be the type of the object that's allowed? Okay? That's the question we want to answer. Okay, so here, in order for the variable assignments to be compilable, what types of variables can appear at the right-hand side? Okay, that's really a critical question here. And we're basically going to apply the knowledge that we just learned. Okay, it's all about expectation, because the issue we are discussing right now is about compilation. All right, so let's now talk about the different possibility. let's see over here. For example, let's talk about SP1. That might be the easiest one to see. All right, so now let's say, okay, I'll say discussion number 1. I have 3 possible assignment here. I can say SP1 is assigned to, let me only use these 3 variables here. SP2, also SP1 is assigned to SP3. All right. For these 2 over here, which one is compilable and which one is not compilable? We want to see, right? What you want to understand would be, in order for this variable assignment to be valid, you want to think about what's the expectation for SP1. How do we expect to use the SP1, which is a smartphone? We only expect to use the dial and surf web. That's the only expectation. So that means whatever variable you're going to assign to it, it should support at least those expectations. They should support at least the dial and surf web. If you are able to support more, that's okay. But it cannot support less. Okay? This is based on the intuition that we spoke about last Thursday. For this one to be valid, the static, the expectation of SP1's static type must be satisfied. What does that mean? In order to satisfy the static type for SP1, which is smartphone, you can choose any of the descendant classes over here, basically. Is SP2 actually a subclass of that? Indeed. You can see SP2 was declared to be iPhone 13 Pro, which is over here. It's guaranteed to have wider range of expectation. That's why I can use it. What about SP3? Indeed, that's also one of the descendant classes. Okay? SP2 and SP3 are both acceptable because their static types are descendants. All right, there's a very important conclusion here. All right, any question? If you're lost, you got to tell me where you get lost because we got to build on this, build on top of this. Anyone? All right, guys, we're gonna talk about many things related to this, from now until maybe next Thursday. So you don't want to stay too much behind about this material here, right? So either you can maybe choose to study a little bit more after lecture today, so you can ask me a question, or you can let me know what question you may have. I can recap once more, okay? Whenever you got variable assignments, you're basically saying, I want to reassign SP1 into something else, like how we said you would do last Thursday, okay? So now SP1 is declared to be smartphone, the static type. So the only expectation I can have on SP1 will be dial and surf web. In order for this assignment here to be valid, I want to make sure the static type for this variable here, in this case, it will be iPhone 13 Pro. I want to make sure iPhone 13 Pro can fulfill all the expectation for smartphone, in which case, true. Because iPhone 13 Pro is lower in the hierarchy. Not only that, it's going to inherit all the expectation from smartphone, but it might have some new expectation as well, which is okay, right? All right, one more. Number 2. When we talk about SP2, right? SP2, and then I'm going to say it's assigned to SP1. And also SP2 is assigned to SP3. Now we want to judge to see whether these 2 should be compilable, right? Same principle. You want to think about here. SP2, if I allow this variable assignment to occur, that means all its expectations should be satisfied, right? What's SP2? SP2 is iPhone 13 Pro. in order to satisfy its expectation, only itself and all the rest of the descendants. In this case, only itself. It's pretty low in the hierarchy, so not many classes, only itself. So when you say SP1, this should not be allowed. Why is that not allowed? If you look at here, SP2 has the expectation for iPhone 13 Pro. Can you actually substitute or reassign that into SP1, which is smartphone? Can smartphone satisfy iPhone 13 Pro? Not really. For example, any smartphone here does not necessarily satisfy QuickTake, which is only specific to the iPhone 13 Pro, right? So this is why this is not good. Right, symmetrically, if you look at SP2 is assigned to SP3. This one here is also not good because SP2 again has the expectation for iPhone 13 Pro. I talk about SP3, which is somewhere over here. Can Samsung satisfy expectation for iPhone 13 Pro? Not really, because this class here is not a descendant of that, so it cannot satisfy. All right, so both of them are invalid. All right, any question here? Yes. It wouldn't work either. That's correct. That's correct. So the only possibility that would be allowed, let's say you want to say SP2 is assigned to something. If you want to say SP2 is assigned to something, the only thing that will be acceptable will be itself, because that's the only descendant class we have. Okay. All right, summary, and then we can move on. So whenever you got some variable assignments, let's say you got variable 1 is assigned to variable 2. You want to judge to see compilation. Compiles? That's the question. You only look at the static type. Let's say, for example, a variable number 1 has the static type, let's say T1. And then, let's say you have another static type of variable 2. Let's say the static type is T2. Of course, the way you check about static type is go to where the variables were declared. Okay? And then we say that it will compile if, okay? There are two ways to see this. Number 1, T2 can satisfy the expectation of T1. Okay? Another way to look at that would be T2 is a descendant class. Of T1. All right, so that's why expectation here is so important. All right, any questions about this? Anyone? Oh, if you're really lost, catch up, and then hopefully you'll be better by Thursday. But reach out to me if you need further clarification. Okay, so let me see the next one. All right, this part here, I just explained. Right, I just didn't read through the slides, but you can definitely use the example there to understand the bullet points over here. And the next one here is just about expectation by static type. This one is pretty easy, and that one there, let me just show to you. Let me go over this very quickly, and then we can take a very short break. Okay, let me go over 2 more examples quickly. Okay. And this one here is saying if you declare Jim to be of static type, students, and what will be the expectation for Jim? When you say Jim dot, what can you put? Well, that's basically the table that we said last time. I'm going to tell you what you can do here. So Jim is students, so you can do name, courses, NOC, and etc. Right? Basically, all the attributes, methods in the student class only, because students is already top of the hierarchy. On the other hand, if you choose another top class in the hierarchy, let's say smartphone, you also got very limited expectation. So if you say my phone was declared to be smartphone, so this will be all the attributes and methods in the smartphone, which will be dial and surf web, nothing else. Okay. Let's see some classes that are lower in the hierarchy, and let's see how the expectation is going to be widened. We already said for gym over here, it's going to be students, so only those attributes and methods. What about if I have another variable here? The static type here is lower in the hierarchy, right? So here, whatever you can put over here will be, number one, all the attributes and methods in the students. That's inherited. Number two, you got the new one, premium discount rate and set discount rate. You got discount rate and also set discount rate. Right, so these are the two, right, combined together. What about the smartphone example? You've got Samsung over here, right? What will be the expectation here? Similarly, it's going to inherit all the expectation from the ancestor classes, everything from there. So that one there, P2 will be the expectation. It will be, number one, you can call the site sync. You can also call the Skype. You can also call the surf web. You can also call the dial. And these two are inherited from this particular ancestor class. Inherited from smartphone class. Okay. Question, go ahead. No, you cannot. So the question was, let's now try to have some follow-up over here. Let's say after these, if I say Jim is assigned to Alan, and this one, according to our rule, it is allowed, right? Now that Jim is now dynamically pointing to maybe some NRS, let's say, can you actually say, let's say Jim dot premium rate, for example. Oh, sorry, that's the non-resident student, right? So let's say discount rate. All right, that's your question. The answer is no. Because when you want to judge to see whether the method call should be compilable, you want to look at whether this particular method here is statically defined in the type of Jim. Jim static type never changes, still students. You cannot do it. So this is not allowed. Because static type of Jim remains to be students. What you can do instead is to do some typecasting, which is we haven't talked about just yet. That will be the topic for Thursday. Not really. If you say Jim is assigned to Alan, in that way, you may just want to call get tuition. In which case, dynamic binding is going to make sure you call the right version for the non-resident student by applying the discount rate. So it does have some value. You just gotta remember, whenever you do any variable assignments, the consequence is the expectation you can have on the variable always depends on the static type. For example, in Jim, you can always just call whatever expectation you have on students. It never changes. If you really want to change it temporarily, you can do some typecasting. But there will be some consequence you got to take, which we'll talk about on Thursday. Okay. Okay, any other questions? Okay. All right, so we talk about, okay. So why don't we take a short break, and then by taking attendance, and then we'll resume. So before the break, we were basically talking about the various example here. So when you do the study back home today, I would suggest you definitely want to go back to this particular, we started pretty gentle today. So I would say go back to this one here to understand about descendants versus ancestor, number one. Number two, given a particular class hierarchy, how can you figure out the ancestor versus descendants and also the corresponding expectation? Because every reasoning that we talk about depends on this. After this one here, you're going to, this might be what you started to struggle a bit, right? Whenever we talk about any variable assignment here, think about the expectation from the two sides. Can the right-hand side fulfill the expectation of the left-hand side? That's the question to ask, okay? And then, so this will be the general rule, which I'm going to talk about once more, okay? We only got about 8 minutes, so let's just go over some slides together and do some example. All right, and then we talk about expectation, right? Okay, so there is so-called rules of substitution that we need to obey. Let's now see the slides and see the story. All right, this is something we discussed right before the break. And then what about substitution? So whenever I talk about substitution, it's just another name for variable assignments. So let's say we got V1 and V2, right? They got different static types, reference variable. What does it really mean when I say V1 is assigned to V2? We know that pretty well. You basically just want to basically say V1 doesn't really point to wherever it used to point to anymore. Instead, it's going to point to wherever V2 is pointing to. That's what variable assignment is doing. And it is important to learn the terminology here, which I'm going to write it down here. Okay. So what we have is this. So we got V1 is assigned to V2. You're basically saying what V1 used to point to over here, not the case anymore. Instead, wherever V2 is pointing to, V1 is going to point to there. Right? That's what the variable assignment is saying. And there's another word that we have to learn here. We are basically saying V1 is substituted. Substituted by V2. This is some new words you want to also get used to. Okay? This is the intuition. Okay? Basically, you're saying this. Before, if I have some expected usage on V1, for example, if I say V1.x, like a method call, okay, or attribute access, doesn't matter. Before the reassignment, before that, okay, if I say V1.x, I will basically be referring to the x of this particular object before the reassignments. But now, after this particular assignment here, when I say V1.x, it's going to refer to the x of this object here that is being pointed to by V2. So we say that we substitute V1 by the object that's being pointed to by V2. All right, think about substitution. And so there are rules that we have to follow for substitution, right? That's something I will show to you, and I will suggest this. I think it will be enough for today. So what you guys should do is, before Thursday, try to look at the rules for 43 is okay. That's something I just illustrated. For slide number 44, it's about the different cases for substitution. I'm going to start from here from Thursday, right? So look at the 3 different cases over here, okay? And then that'll be it. All right, so make sure you really catch up with what I spoke about today. And in the next lecture on Thursday, I'm going to recap the substitution rule, talk a little bit about dynamic type, and then we will be ready to talk about typecasting. All right, thank you. I'll see you tomorrow in the test.